This video is actually going to be part one of two parts. The first part's going to cover linear inequalities in one variable. So what we're going to focus on in this video is how are linear inequalities solved and graphed in one variable. In the next video, we'll focus on absolute value inequalities. So solving a linear inequality is almost exactly like solving a linear equation. So if you look at this problem here, this symbol acts almost just like an equal sign, and I need to solve for x. So to solve for x, we would subtract 3 from each side, and we would end up with x is less than negative 3. Notice here the graph of this inequality. I'm going to go ahead and put the parentheses in. And I have a parentheses because it's a less than. It's not part of the answer. Notice the difference between the previous example and this example. I'm solving the inequality the same way. I added 4 to each side and ended up with x is greater than or equal to 4. However, when I go to graph it, I'm going to put a bracket in rather than a parentheses because of the equal to that's part of the inequality. The example here is what's called a compound inequality. It's compound because there's 3 parts to the inequality that need to be solved. So you're going to treat this just like you would an equation where there would be 2 sides, except now you've got 3. So I'm going to focus on the center part because I want to get x by itself. So the first thing to do is to get rid of the plus 4. So we subtract 4 from all sides, and we end up with 6 is less than or equal to 3x, which is less than or equal to 15. We now need to undo the multiplication, so we will divide all 3 sides by 3, and we end up with x is between 2 and 5. Let's look at what this graph is going to look like. Notice we have the equation solved above, the inequality solved above, and I'm going to go ahead and put 2 brackets, one at 2 and another at 5. And I've put brackets because it's less than or equal to. If it were just a less than symbol, we would just use parentheses. One last rule that we need to look at in terms of inequalities. Anytime you multiply or divide by a negative number, you have to change the direction of the inequality symbol. I want you to think about why that happens. Negative numbers work the opposite way that positives do. The further from 0 you get on the positive side of things, the bigger you are. The further from 0 you get in the negative side, the smaller you are. So if I'm going to change the sign of the numbers that I'm dealing with, then how that inequality symbol works will be flipped. And that's what's happened here. We've gone from a less than, because we were dealing with positives, to a greater than if we're dealing with negatives. So I'm going to work through 3 more examples with you. For the first one here, we're going to divide each side by negative 4. Because I divided by a negative, we're going to flip the sign, and we're going to end up with a is greater than or equal to negative 9. On a number line, we would have a bracket at negative 9 and then shaded to the right. Remember, the inequality symbol, if you think about it as an arrow, points in the direction that you need to shade. For the second example, we're going to add 7 to both sides. So we have 2y is less than 16. Divide both sides by 2, so y is less than 8. And then finally, we've got a compound inequality. I've got division that needs to be undone. So I'm going to multiply all 3 parts by 3. So we have negative 3 is less than or equal to 5y plus 2, which is less than or equal to 12. We'll go ahead and subtract 2 everywhere. So we have negative 5 less than or equal to 5y, which is less than or equal to 10. And then we'll go ahead and divide each side by 5. So we've got negative 1 is less than or equal to y, which is less than or equal to 2. This is brackets because it's equal to. So I would have a bracket at -1 and a bracket on 2. So that is really the nuts and bolts of linear inequalities. The next video that you watch is going to be on absolute value involving inequalities, but I want you to practice some problems first.